So at a high level, Riak is a key value data store that was inspired by Amazon's Dynamo paper. It's written mostly in Erlang and is open source under the Apache 2 license. To expand upon the key value design, we've also added some extras, such as a full text search, secondary indexing, map reduce, pluggable backends, and much, much more. Riak is designed for high availability, so you can always read and write to it, no matter how many nodes are down. Low latency, horizontal scalability, fault tolerance. Again, nodes can go down, but your system's going to stay up no matter what. Ops friendliness and predictability. So Riak is based on the CAP theorem, and the CAP theorem states that in the event of network partition, a distributed system can either provide availability or consistency. Riak is built to favor availability above all else. Additionally, it's, as mentioned previously, it's inspired by the Dynamo papers. So Amazon created this to power their shopping carts. Again, a feature that needs to focus on availability over consistency, as it has a direct impact on their revenue. So to go into a little more in-depth details about Riak. In Riak, objects are stored as keys against values. These keys are then grouped into higher level namespaces called buckets. And Riak is completely content agnostic. You can store any type of data into Riak, and it's all stored as binaries to the disk. So as you can see, when you input a key, it's connected with your value. And then this can be in the higher level bucket space. So certain types of data fit really easily into this key value data model. Some examples include session data, especially as it relates to any sorts of logins, user player data, advertising for campaigns that can then hold ad content, sensor data, as well as just general content. As I mentioned, it's completely content agnostic, so you can put any sort of content in there, text files, images, video, anything. Riak has two primary APIs, HTTP as well as protocol buffers. There are also a number of querying methods for Riak. We support simple get, put, delete options. We have full text search. We have secondary indexing that allows you to tag all objects at write time with metadata that can then be queried for exact matches or ranges. And then we also offer map reduce. There's also a number of client libraries available that are supported by either Basho ourselves or our great community. These are available for basically every major language that you could think of. So we mentioned that Riak focuses on availability, scale, and fault tolerance. So let's go into a little more detail about how we do that. So for one, Riak is a completely masterless system. You can read and write to any node, and when a node fails, the system remains available. It's deployed as a cluster of nodes, and we recommend having at least 5 nodes in your cluster to begin. One of the biggest benefits of using Riak is that it automatically distributes your data across the cluster. This means that you're not going to need to have any need for manual sharding, as all of this data is automatically redistributed, distributed across your cluster, as well as when you add new nodes, the data gets automatically redistributed, making it really easy to scale your cluster up and down. So how we handle this is using consistent hashing. So if you start with 160-bit key space, which is here shown as a ring, this ring is then divided into 32 evenly sized partitions. So let's say we now have 4 nodes in our cluster, which means that each of these nodes is going to be responsible for 8 partitions. When you write to the cluster, any of these objects are written automatically to n partitions. And so the default of n is 3. So that means you have 3 replicas in your ring. And then what happens if a node fails? So basically, our system handles node failure through something called hinted handoff, which would be similar to if you go on vacation, your neighbor would be collecting your mail for you and then delivering it back to you when you return. So when a node fails, all of the read-write requests go to neighboring nodes that also have replicas of that data. And when a node comes back, these neighboring nodes can hand off any of the updates or writes to the node that failed. And then once everything is passed off, normal read-write operations can resume. So given the CAP theorem, since Riak favors availability over consistency, sometimes it may be possible that there are divergent versions of objects in Riak and that the system may not deliver you the latest object. To help improve consistency within the system, we created active anti-entropy. This allows for automatic self-healing, and it runs in the background. So it uses a hash tree exchange to compare replicas of objects and automatically repairs any objects that are divergent, missing, or corrupt. And since it's running in the background, it also has a minimal impact on performance. So now to get into a little bit of what we've added with Riak 1.4, I'm going to pass it off to Tyler.
Thank you, Alex. So we're going to start with talking about the concept of eventually consistent counters. If you weren't able to attend our Recon 2012 event in San Francisco, there's an excellent talk about the concept of distributed counters. I encourage you to look it up. I also encourage you to attend Recon West, which is coming up in October. But eventually consistent counters are the first publicly available distributed data type in Riak. These PN counters are capable of being both incremented and decremented, and they provide automatic conflict resolution after a network partition. Handling counters in an eventually consistent system can be challenging. And so we've gone through a lot of effort and dug into a lot of research around a concept called CRDTs, which is scary math, to enable you to begin to deploy data types. There will be more of these coming in the future. With 1.4, we've rolled out the first. We've also made a fair few updates to secondary indexing. So 2i queries are now sorted, and a client can request only the first n results. This is huge for those of you who use secondary indices now. To allow you to sort that, it really allows for greater operational friendliness. Also, there's pagination that allows queries to begin where n left off to deliver the rest of the results. You can actually page through the list of results in order. You can view start values, continuation values, end values, min and max. You don't have to hold everything in memory at once during the query state. You're able to get it as needed. We've made some additional updates to Riak Control. If you're not familiar, Riak Control is Riak's sort of GUI administration tool. We've updated it to add a cluster management page that allows for staging so that you can see how node changes will affect your cluster before you commit the changes. For those of you who are using the command line interface for this already, Riak Control now has all of those features with some added visualization capability. It's pretty cool. There were a whole slew of other features in 1.4. Progress bar for handoff so that operators can have more visibility into the handoff process. We went ahead and reduced the object storage overhead. This is best for small objects. We're using a more compact format than we have in the past. This allows for space saving related to siblings and metadata. This is not turned on by default if you are upgrading. There's a process to upgrade those objects. Take a gander at the release notes to learn about that. We've done a fair bit of updates to the protocol buffers interfaces. Now all of the known properties are available, and you can bind the protocol buffers to multiple interfaces and ports, which is good for those of you that have both internal and public interfaces. Overload protection for vnode processes really ensures that Riak is going to remain stable even in unexpected scenarios by delivering an overload message if there are too many messages in a vnode queue. That's configurable. Again, more information on the documentation, docs.basho.com for that. In addition, we've added the capability of cascading real-time writes for Riak Enterprise multi-data center replication. There's a lengthy discussion about that on the docs site, but it enables you to build some interesting topologies for replication when you're leveraging Riak Enterprise. We'll talk about Riak Enterprise a little bit more in a bit. So with that said, when does Riak make sense? Alex is going to walk us through a few use cases where Riak could be a great solution for you.
Yeah, so some things to keep in mind with Riak, because of how it replicates data, we recommend that you really should only use Riak if you have enough data to require at least 5 nodes. Riak, again, makes sense if you have data that requires availability over consistency. So we call this critical data. So any data that you absolutely need to have access to at any point in time. And then any data that can be modeled as keys and values. Don't be afraid to denormalize this value, though. A lot of times people can be turned off by the key value idea, but many types of data can fit into the key value model if a bit of thought is put into it ahead of time, and it can end up being a lot easier to handle in the long run. So let's look at how some of our customers are using Riak. So one of them, Stratius, which was recently acquired by Dell, uses Riak to power their cloud infrastructure management platform. They store machine, customer, and API data and needed a fault-tolerant and scalable solution. Previously, they were using MySQL, but as their data grew, scaling became a huge bottleneck for them due to the need of manual sharding. Additionally, having the master-slave architecture meant that they had a single point of failure. They also required multi-site replication, one of the features in Riak Enterprise we'll discuss later. They selected Riak because of its automatic redistribution of data, making it easy to scale, so eliminating that sharding need, and the masterless design available with Riak. Again, eliminating the single point of failure. On our site, there's a great talk by Stratius CTO, George Rees, about the process of moving from MySQL to Riak. And so you can find that either on our site or on Vimeo. Best Buy is also a customer of Riak. They use us to power their e-commerce platform. And Riak has been an integral part in the transformation push to re-platform Best Buy's e-commerce platform. On our users page is a talk from their director of web architecture about how Riak fit into this idea of innovation at Best Buy and how he was able to push Riak through in a larger enterprise setting. Also on the retail front, Copious, which is a social commerce marketplace, uses Riak to store all of the registered accounts and tokens for Facebook and Twitter logins. So basically any of their users, they require them to log in via Facebook and Twitter. And once they're all logged in, Riak stores those tokens. They've also been so impressed with Riak's operational simplicity. They're also looking to move more data over to Riak. Mochi Media, which is a Flash-based gaming platform, was actually the first Basho customer and started using Riak to store session data in 2009. Since any latency or unavailability would directly translate to lost ad revenue for them, they needed a system that would serve data quickly and reliably. They selected Riak and use it to store social graph data for both Mochi Social and Mochi Games. OpenX is an ad technology platform, and they served over 4 trillion ads last year. They originally were using Cassandra and CouchDB, but they moved over to Riak to store all of their user and trafficking data. They're also a Riak Enterprise customer to provide multi-data centers throughout their global infrastructure. On our users page, there's a video from one of their engineers that goes into more details about why they chose to switch to Riak from CouchDB and Cassandra and how they're using it. Voxer has a very unique story in that they experience exponential growth nearly overnight. Voxer is a walkie-talkie app for smartphones that had the success once a celebrity tweeted about them, and their usage grew exponentially. To accommodate this viral growth, they had to quickly scale up using Riak. They originally only had a 10-node cluster. And now they're running about 60 nodes in production and store hundreds of terabytes of data, with more terabytes being stored and served every day. They were able to have this exponential growth fairly seamlessly. Their system never went down, and they were able to handle this growth in traffic. Riak also supports their 400,000 concurrent users and has never gone down. So on our users page, there's a lot more case studies about companies switching from different different solutions to Riak or using them as hybrid solutions, which is something we've seen a lot more. Not one database can do everything for every company. And so a lot of times a polyglot solution is the right way to go. With Riak, we've seen many of our users using us alongside Postgres when they need an RDBMS, or Elasticsearch and Hadoop. When running complex analytics, it may be worth setting up a secondary analytics cluster, which is something that you can do with Riak Enterprise with the multi-data center replication. This way, if you have any complex analytic operations, they're not going to affect the read-write latencies on your primary cluster. For hosting options, you can try us on Amazon. We have with the Amazon AMIs. We're also on Azure, Engineer, Joyent, as well as Software. So while Riak is completely open source, we also have this commercial extension that we mentioned called Riak Enterprise. So what Riak Enterprise adds is multi-data center replication as well as 24/7 support. For replicating data across data centers, we offer both full sync, which syncs all data configurable intervals, and this default is sent to every 6 hours, as well as real-time sync. So whenever there's an update to your data, it's going to write the update across clusters. We've also made some changes to Riak Enterprise with this 1.4 release. And one of them, as discussed earlier, is with the cascading real-time writes. However, we also offer what we call version 3 replication, which is available with 1.4. And this supports SSL, NAT, as well as full sync scheduling. We've also added more TCP connections between clusters, making the syncs faster, made it easier to set up, and have improved per connection stats. Alongside Riak, we also have an open source cloud storage product called Riak CS. This provides large object storage and is S3 compatible. It also provides multi-tenancy and per user usage reporting. Riak CS 1.4 will be available in a few weeks, so be on the lookout on our blog and our site for more updates about the timing of that. So our next Riak release is going to be 2.0, which is going to come out later this year. 2.0 is going to add a lot more exciting features, such as tighter Solr integration for full text search, continued improvements with consistency, dynamic ring resizing, and faster data transfer between clusters and multi-data center replication using the active anti-entropy we discussed, and many, many more options. You can check out GitHub to get an idea about what's to come, and let us know if you're interested in testing any of these features as a technical preview. So, as mentioned earlier, Basho also hosts a distributed systems conference called Recon. We wrapped up Recon East in New York in May, and tickets to Recon West are now available. I believe early bird tickets are available through August. So we already have some great speakers lined up, and you can check out recon.io for more information and to buy a ticket. Thank you all for joining us. I'm going to stick around for a bit to answer some questions you might have, so feel free to type them either in chat or send me an email. It's just alex@basho.com. Thank you all for joining.